Okay, everybody, now that we've been working with radical expressions so much, I want to go back and talk about the word rational. In this module, we were going to talk about when your expression has a rational exponent. So we all know what an exponent is, and we all know what the word rational means because we've already discussed that in this course. Rational means fraction. So in this module, we're going to talk about what happens if your expression has an exponent that's a fraction. Well, let's first recall that we understand the meaning of an exponent. So if you look at your PowerPoint, my first expression is 9 squared. So we know 9 is the base and our exponent's 2. And if we look, our exponent's a positive whole number. And we totally by now understand what that means. We know 9 squared means to write that base twice connected by multiplication. So we know 9 squared means 9 times 9, which is 81. We've also already learned how to deal with an exponent that's negative. That's a whole number. So if we look at our next expression, we have 9 to the negative 2 exponent. So we know our base is still 9, but now our exponent is a whole number, but it's negative. It's negative 2, so it's an integer. But we've already dealt with this. We have learned that you cannot have a negative exponent because it doesn't make sense. How would I write the base 9 negative 2 times? I can't. So we've learned already in algebra, anytime we see a negative exponent, we wave our magic wand, change it to be a positive exponent by doing the trick. And the trick is you do the reciprocal, the multiplicative inverse of the base. Sound familiar? So if I have the expression 9 to the negative 2, I first have to rewrite that with a positive exponent. So I take my base 9 and do the reciprocal of it, which would be 1/9, and now my exponent would become positive 2. Now I understand what that is asking us. That expression is saying take 1/9 squared, which means do 1/9 times 1/9, and we know that. Multiplying fractions is no problem. Top times top, bottom times bottom, and we would get 1/81. So far in this course, we've learned to deal with exponents that are positive integers and exponents that are negative integers. What we have not seen yet is an exponent that's a fraction. So everybody look at my next expression. It is 9 and the exponent's 1/2. It's rational. It's a fraction. Well, we got to learn what does that mean. It does not mean what you think. A lot of you think that means take 9 and cut it in half. That does not say take 9 and cut it in half. If I wanted you to do that term, I would write 9 divided by 1/2. So I'm not asking you to do division here. I'm not asking you to do multiplication here. What I have to show you guys and gals is what does it mean if your exponent's a fraction, a rational number. Well, what that means is you're going to have to rewrite this expression because the definition is every exponent that's a fraction can be rewritten as an expression that has a root and an exponent. If you look in your PowerPoint, there's a definition here that says b to the mn. So your base is b, and your exponent's a fraction. It's got m in the numerator and in the denominator. That will always be rewritten as a root. And if you look, the base went inside the root symbol, so the base is the radicand. On the base, there's still an exponent, but it's just now the numerator m, and the root is the denominator, the value of n. So what you're going to learn right now and how all this ties in is anytime I write an expression that has an exponent that's a fraction, you need to rewrite that as an expression that has a root and an exponent so you understand it. So guys and gals, if I have the expression 9 to the 1/2, I don't understand that. I've never understood how can I work an exponent that's a fraction. An exponent's got to be a positive whole number. So what you have to do is you have to rewrite that. So the base is 9. The 9 goes inside the root symbol. The numerator 1 is still the exponent on 9. So if you look, I have 9 to the first inside the root symbol. So 9 to the first is inside. That's the radicand. The denominator 2 is your index. Well, do we write an index of 2? No, because it's understood to be a square root. So when I write the expression 9 to the 1/2, that really means I'm doing the square root of 9 to the first. Make sense? Look at my next expression, 8 to the 2/3. That doesn't make sense. How can you take base 8 and write it 2/3 times? You can't. So we've learned since the beginning of this course, exponents must be positive whole numbers to understand their meaning. So if your exponent's a fraction, that's telling you you must rewrite this expression. And when you rewrite this expression, it will have a root and it will have an exponent. The denominator of the fraction is the root. The numerator of the exponent is still the exponent. So when I have 8 to the 2/3, what's my base? It's 8. So 8's going to be inside. It's going to be the radicand. It's still going to have an exponent on it, but the exponent is not going to be a fraction. Now the exponent is going to be the numerator, just the 2. The root, the index, is going to be the denominator, which is the 3. So we would rewrite 8 to the 2/3 as the cube root of 8 squared. And once we rewrite it as a root, now we understand how to work with it. So the moral of the story is, if you see an expression with an exponent that's a fraction, your first job is to rewrite it as an expression that has a root. And that way you'll understand what this expression means. Okay, we're going to practice some more of this in our next module. See you then.